So today we're going to talk a lot about a new set of labor units that our committee developed over the last 2-3 years called the work activity method. So some of you that have a reference of the MCA labor units that goes back decades, we're going to refer to those as component method units, and we'll explain that a little bit further. And I would assume that most everybody in here knows about or uses the MCA labor units. So can I get a show of hands? Who uses MCA labor units when they estimate right now? Is that pretty much everyone in the room or close to everyone in the room? Okay. So today we're gonna not get into too much detail on the background of how that was originally created, but we're going to focus in on what we've done that's new and how to apply the work activity method for labor calculations. And Ron's going to get into a couple detailed examples so that you can see this better. I would ask that you raise your hand and ask questions at any time we're going through this. This is meant to be entirely informal. We're here to answer questions more than do the presentation. So as we present information, if it doesn't make sense, just shout out, and we'll take those as we go. So the WebLEM committee itself has been around, Ron, how long? Since the 60s? 68. It is intentionally made up of a diverse group of contractors, diverse geographically and diverse from an industry standpoint. So we try to represent everything from commercial to industrial to even clean room high purity work, from the north to the south, the east and the west. And you can see the members that are on the committee. Kevin from Houston, their company is a plumbing company, plumbing only. Paul DeBella from Santa Clara, California. They do a lot of high purity computer room and biofarm work. Bob Durr from New York, and Bob's company does a lot of industrial work, power plants and water plants. Andrew Hostler is brand new to the committee from Performance Mechanical in Pittsburgh, and their company, I think, is a mix of institutional and industrial and commercial work. Ron King, who's with Trimble now, previously with Gem Industrial out of Toledo, and Gem, I think, is mostly an industrial contractor. Pat Riley with John Danforth. John Danforth has actually been represented on the LEM committee going back to, I think, its very inception. Yes. So they're the one company that's had involvement since the 60s on the LEM committee. Myself with the U.S. Engineering Company here, and then we have an affiliate with the MCA office in Washington, D.C., Nick, that helps us out and helps us stay on task. So what were some of the reasons why we decided to take this on? Before we took it on, we had somewhere around 200 to 250,000 data points in the WebLEM. So you remember that old book that was 4 inches thick? That's all, been put online. There was a little less than 250,000 data points previously. When we decided to take on the work activity method, we recognized that we weren't necessarily going to double that. I don't think we're going to double that. But we're going to add more than 50% to it by the time we get done. So this is a lot of work to generate another 100,000 data points by our committee members. So why were we doing that? The reasons that we were doing that, and we debated this. This wasn't a quick decision. Ron actually has been more passionate about this than anyone. With his background with the John S. Page unit, some of you that do industrial work know about the John S. Page Book of Estimating, which is similar but different. But the reasons are to be able to separate labor between shop and field. That's the biggest driver. Inability to account for labor associated with back-to-back fittings. So in the component method, if I take off a pump hookup and I have a valve up tight to a fitting, when I take off that fitting, being an elbow or T, I have a joint on either side of it, and when I take off that valve, I have a joint on either side of it, and if I put those two back to back, I've doubled up a joint in that takeoff. That starts to explain why when you're doing a takeoff in an equipment room or at an air handling connection or something like that you factor more heavily normally. Okay, that starts to account for that, and Ron's examples will show this real clearly. Inability to break down all labor components of a joint, like contractors would like to know, what should it take for me to put a joint together? And the component method doesn't really easily allow you to do that. People have historically taken the labor for a cap and said that's as close as we can get them. And it's not all that far off. It's a little bit high, but it's as close as they could get previously. better cost control of labor activities in both the shop and the field. So those were the driving reasons. How do we do it today? By the component method. We establish shop versus field labor hours by a couple ways. If you take off by the component method, then you make a guess. How much percent's going in the shop, how much percent's going in the field. In our company, I know the PM and the estimators do their best guess at that. And that's how you set your labor codes up and your productivity goals, and you hope to God you got that breakout right. That's probably the best that most people do. You can use a diameter inch method. Most fab shops that people have know basically what their production rate out of those fab shops are. They get 3 inches per hour out of the fab shop or whatever that number is, and you can count the joints back into that number, subtract it from your estimate. That would give me a breakout. So that would be another way you could do it. We account for back-to-back fittings by applying a correction factor like I mentioned. That's part of the correction factor. And one of the big red warning flags that I'm going to say and Ron's going to say is if you go out of here and you go use the work activity method units, you need to take your history of what your labor factor has been and throw it out the window, because that historical labor factor you've been using will not apply to the work activity method because we've taken all that redundancy out now. So if you use the same factor you used to use, you're going to get the job. Okay, that's the bottom line on what's going to happen. And people need to understand that. So that was another argument we had internally. Should we publish these? Is this going to get people in trouble? And ultimately we decided education was a better course than not publishing it. Currently, no way to break the joint down, as we mentioned, and we use a cap. So that's what people have done. Another question is, when I take off a fitting, an elbow, for example, a 90, what's in that 90? So here's an example of, a 6-inch carbon steel, standard weight butt weld, long radius 90L. The LEM right now, if you go onto the WebLEM and you pull it up, it's going to tell you that's 6.29 hours, which includes receiving, unloading, stockpiling, distributing, the joining method, so it's, in this case, butt weld. It's got 2 joints, it's carbon steel, it's standard weight. It has pressure testing, normal pressure testing being 1.5 times the operating pressure. It has installation or erection. And if you were to break all those components down, you'd find that the bulk of it is made up by making the joint and handling it and getting it up into the location. Okay, and one thing people don't understand is the component method units, all those 200,000 units that we've had for decades, those are generated by an empirical formula that has factors for each of those items I just talked about. So for every material joining method, wall thickness, there's a formula that we apply that allows us to calculate that unit, and the way the work activity method was developed is breaking that formula apart and publishing the pieces of it. Okay, does that make sense? So that's the challenge. How do we establish meaningful hours for the fab shop? And we want to get down to this kind of a detail that we can give to people so you know what all of those items are. Cut and bevel, TIG root, joint, like a butt weld, a hydro test, preheat, post-weld, heat treatment if you've got it, and other things. So, when you go down into this kind of detail, now you can think about, and we were talking with Bob earlier, there's a lot of information in the work activity method that's been published now. How do you use it? And that's the challenge that we're trying to work with software companies to address, because I think at the end of the day, it's great information, but you guys aren't probably going to use it till software vendors pick this up and provide a product you can use to make it easier, because that one labor unit now is broken into all of these. And we talked about what to call it, and that's where we came up with the component method for what's existing, and the new method being the work activity method. So somewhat self-explanatory once you understand what the 2 bases for these are. It's pretty self-explanatory. So how does it work? And we're going to do a really simple example here. So the same carbon steel butt weld 90 that we talked about before, I think was 6.29 hours. If you go to the WebLEM, look that up, that's the number you're going to find that's published on the website. If we break that apart, you can see that the cut and bevel, 2 joints, is 0.8 hours. making the joint itself, the butt weld, is 4.96, and the installation of that elbow is 0.41. So if I add this all together, I get to 6.17, and you'll find if I take that and add 2% to it, I get exactly to that number, bang on. Exact number. So that 2% testing is something, keep in the back of your head, that'll come up later when Ron talks, because one of the things we also recognized is that testing the way it's currently included in the component method is included at 2% of the total labor, which will do an adequate job, as most of us know, if you've got a commercial installation where you're just testing the whole system out on site. But when you start breaking down testing, hydro testing in your fab shop by spools and having to add flanges and blinds and things to test each spool and then bolt it up in the field and test it again, that 2% would never suffice. And so testing then becomes also an additional takeoff item that we would talk about. So let's look further into this. Changes that we made. Now, I think all of you said, pretty much everybody in here raised their hand and said that you use the MCA labor units. Honest show of hands, how many of you have actually read the introduction, the proper use of the LEM, and the basic assumptions and the correction factors? All of them. One person? That's actually more than I thought that it would be. So our committee fields a lot of questions, and I'd say half of them are answered by just telling them, go look at those. Okay, because a lot of things are described there. And if you go look at the WebLEM here real quick, and this is the WebLEM and what it looks like. Everybody here, if you're an MCA contractor, has free access to this. If you don't have it, call the MCA office. Nick will get you set up with username and password. Password automatically changes about every few months. You get emailed a new password. You are allowed to share that password within your company to anybody in your company to have access to it. This is what the website looks like. And those documents that I mentioned are here, so I'm just going to pull one of them up. And if you get into this, so these documents, these PDF documents, all had to be modified when we started to take on the work activity method. So if you've read those before, it's time to read them again, because they've all been modified in some way, shape, or form. Most importantly, not just the introduction or proper use, but these basic assumptions and the correction factors really have a big impact on how you do your takeoff and making sure that you get everything correct. So all of those things really got modified. The addition of the piping systems folder, I guess I probably should have stayed there to show you that as well. So all of the labor units now, for most of the pipe valves and fittings, everything you do in your takeoff is in this one folder called Piping Systems. That's why it's red. And if I open that, there's a gigantic warning sign here. And what it basically says is don't mix the two units. Okay, if I do part of my takeoff in component and part of it in work activity method, there can be problems with that. I would tell you, you could easily do component method takeoff outside of a room, like a chiller room, and inside the chiller room do work activity method and probably be okay. But the minute you start mixing and matching labor units from the two systems within an area, you're going to make some mistakes most likely. And we highly recommend against that. Choose your method and go that way. So here, that's what this sign is saying. The component method units, everything that relates to it is here underneath component method. You can see all of those. And the new work activity method units are here. And you're going to see that there are different kinds of folders here than what we've had before, because that one item, an elbow, is broken down into all of these different things. And you can see what the folders are. And you'll also find, when you look at this, that there may even still be some empty folders in here. I'm not sure if there are or not. Yeah, there are. So drilling holes and fillet welds and machining inside of pipe and layout and flame cutting, we're still working on this stuff. So, you know, if you find an empty folder here, that's because we're generating those units now. There's also HVAC hookups, instrumentation, miscellaneous labor operations, those all had to be modified as well. So for example, the hookups that are in here, I guess they're not actually there. They exist up here. Yeah, so here's plumbing hookup and here's an HVAC hookup. And if I pull this up and look at the notes, you're going to find real quick that the hookups are all taken off by the component method. Okay, so that's the way that they are currently done. They're all based on a takeoff using component method. Our committee, we at times have had a lot of requests from users to generate a lot more hookups, and we're not going to do that. The hookups are there as an example. They're not meant to be there to help give you an estimating system. That's what your software is supposed to be to do. You set up your own assemblies, whether you're using Trimble's product or someone else's product. Our committee isn't going to spend its time creating assemblies and giving you an assembly number. That's something we expect you to do. The purpose of the hookups is to show examples. So that's why they're there. Instrumentation and equipment. I mean, some of these things when we started off on this road, we weren't really sure what we were going to get into, but if you think about instrumentation, a lot of the instrumentation items are a combination of an item and a joint, just like a fitting would be. And as a result, we realized all of those items are currently calculated by the component method. And so long-term, the vision is that we believe our members should be able to choose to do the entire estimate by the work activity method or the component method. Meaning that if an item exists in the component method, like in instrumentation right now, we ultimately should have a way for you to take that off in the work activity method. Meaning we've now got to create new units for every item in that manner. Let's see if I can get back on course here. So miscellaneous labor operations. There actually were some work activity method activities within that folder that became redundant when we created the work activity method units. So cutting was in there, for example, I think, if I'm not mistaken. Cut and bevel was in there. Well, all the cut and bevel now is in the work activity method folder, so we took them all out of the miscellaneous operations. You won't find them there anymore, so if you're not sure where they are, go into the search bar in the upper right corner and type it in, and it'll take you to where it currently is. That search function works pretty well. Plumbing equipment, plumbing hookups, treatment plant equipment. One of the other changes that we had, for example, in treatment plant equipment is in treatment plant equipment previously were all the valves that were specific only to treatment plants. We made a decision to take all of those out of there and put valves with valves. So if you're looking for a treatment plant valve, it's not in treatment plant equipment anymore like it used to be. It's in valves under the component method, or it would be in the work activity method. Okay. Those are changes. In the work activity method, you're going to find these folders. A lot of these are new. Showed you most of those earlier. Most of them are pretty straightforward. But an example where something you don't necessarily think of, so bolt up, the very first one. So previously, if I had a weld neck flange, that weld neck flange labor would include one joint on one side that's butt weld for the weld neck. On the other side, it would include a bolt up. Okay, and it would include the labor to get that in place. So now on the work activity method unit, I still have a weld neck flange. I still have to handle that and install it, but then I need two joints. I need a bolt up and I need a weld joint. So you can start to see how this becomes a lot more pieces to match up with the component method. Some of these, as we mentioned, we're still working on. The fillet welds, we're actually still arguing over a little bit what the right approach to that is. Drilling holes, I mean, we're prioritizing this based on what we think you guys are all going to use the most and trying to get that knocked out as we go. So as we publish things, we're publishing things we think our members are using most commonly. The rest of this, I think, also pretty straightforward. That's the list of work activity method folders. So we're going to go through an example. At this point, I think I'm going to turn it over to Ron, and he's going to take it from here. This is an air handling unit example. Can you get that?
It's like putting a corsage on. You don't do it yourself, right?
And it doesn't go in very far. It just gets to the very tip. That's all it's going to get.
Okay, cool. So as Tim said, this is a coil assembly that on an air handling unit, one of the jobs that they did. So I'm actually going to bring this up and show it to you in Navis. But before I bring this up, I wanted to just illustrate another point. When Tim was talking about the WebLEM and he was on that WebLEM site, I want to make sure, since most of you raise your hand, that you use the WebLEM. If you're not getting updates to the WebLEM, whenever I have MCA contractors together, I like to just mention this point. If you're not getting your updates, and we get them usually about twice a year, it's because we've got the wrong email address for your particular company. So each one of you have a representative that has been given their name to MCA with an email address. And every time that our committee sends out an update, we also get an exception report that tells us who didn't get it. Tim, how many was on that last one? Is it 1,000 people? I mean, it's a lot of people don't get the update, right? Because quite simply, MCA's got the wrong address. So if you're not getting your updates, that update email, whoever's a champion within your office, make sure that the main office at MCA's got the right address. Bob could forward it on, or just get a hold of the MCA office. So I think that's really important, and I like to just bring that up anytime I've got MCA people together. So anyway, so this particular coil, if we go out and we look at it, and I'm going to just go bring this up in Navisworks so we can kind of look at this a little bit better. This is a very large coil. The header on this thing was 6-inch running this way, 3-inch on, 6-inch on the header this way, 3-inch on these the horizontals going in. But the real point when I look at this thing is this. In this assembly, because we've got a lot of fittings that are back to back, we're going to have naturally joints that we don't need, weld joints. So for instance, you take this T right here, you've got a concreducer welded exactly right off the branch of that T. And then off the concreducer, we've got a flange welded onto it. So if I were to take this off in the old component method, obviously with this flange, I'm going to get a joint right there for that flange, but I also had 2 joints coming off the concreducer and 3 joints coming off the T. So you can see right away we've got joints that we don't need. On top of that, the biggest thing is the cuts. So right or wrong, the forefathers, when they figured out the formula that we use for making our labor units for the component method, every opening to a fitting has a cut associated with it, because we don't know where you're going to put that. You might have needed to cut a piece of pipe in order to make that joint on every side of that fitting. So when you take something off using the component method, you've got a lot of cuts that you're not going to need. And this is going to illustrate that really quickly when you see it. So that was the first example that we're going to use is this coil. So the entire coil is in this example. Now, so the limits of the boundary of the coil basically start at the hookup where it goes into the coil, and it quits right here. Okay, so going back to the main, and then this little section of piping was not in this example. So basically it's picking it up at the elbows on the supply and return, and then taking it all the way over to the coil. So that's what the example shows. Okay, so now when we go back in and look at it, let's go kind of pull this together. So there's an Excel spreadsheet that what I should probably do is I'll give Bob my email address. If anybody would like these Excel spreadsheets, I can email them to you so you have the example, because I think it's really good to have that back at your desk to glue this together. So unfortunately, I didn't make copies of this, but if you want them, I can email them to you. So let's look at doing this the actual component method. So I'll switch over to it. And this is a takeoff of all of the items that was in that coil assembly, starting off with the pipe, the couplings, the 90-degree elbows, the flanges, the T's, concreducers, and the unions. So as Tim mentioned before, in the component method, which we're looking at right there, these are the labor units that are coming straight out of the WebLEM, and they include everything, the joining, the testing, the getting it up into place, everything inclusive of getting that item put up. So when I should turn my Outlook off when I didn't, sorry. So this particular spreadsheet just extends everything out times the component methods labor unit, just like you've been doing today. Now what's significant to look at here is there are no joints listed in this, so as you go down through there you won't see any joint count, because today if you were to count your joints using the component method, your answer would be 0 in labor, right? Because that labor is already included in the item, right? So you wouldn't have anything there. That's why I didn't list it on here. So we come up to the very bottom and we've got 1,186 hours. So and this is 1.0 MCA, no factor applied. So if you were to take this off today's method before the work activity method, that's the number you would have come up with, is 1,186 hours. Now if I take it off using the work activity method, again, you're going to have the same material up here listed all the way down. And the only difference now is the labor hours that we're using. Those labor hours are the work activity method, which are only the handling component of those hours. So the handling it through your shop or getting it into the field. Now, when I come down and I look a little further down now, I start to see some things that I wouldn't have had in my component method, such as now I'm counting the number of bolt-ups I have, number of joints that I have, and on and on. So as you see with the bolt-ups, there's the hours for those. Then we start coming down and we start counting joints. And then also the cuts that are involved with those joints, whether they're butt weld, they're threaded, they're socket weld, or whatever. And then we come up, there is the total number of hours on that is 893 hours. We added in 2% testing on the very bottom, because that's what the formula would have had to compare apples to apples. And we now have 1,003 hours to do it, the work activity method. So as you can see, there's a big difference between 1,003 hours and that 1,186. So basically, the difference in there is the number of extra joints, back-to-back joints that we didn't need for the actual weld itself, or the cuts involved. So that's pretty significant. So earlier when Tim said, when you go back and you start using the work activity method, you got to make sure that if you were using, I'm just going to throw a multiplier out of 0.75. If you're using a 0.75 multiplier on the old component method, you certainly don't want to then take this number and put a 0.75 against it, because you will get the job. You know, I don't know if you'll make any money though, but you will get the job. Now, it might scare you a little bit and say, okay, but hold it, you know, I don't know about that, because I've had those dialed in for a long time. It's very simple to go back and do a comparison between your work activity method number that you're coming up with now to the old component method. So you simply would do this. You would take it off the way that you did it before. Most of the software companies will, all their software will extend out by multiple labor columns, extended out by the labor column that you've used all along, the MCA labor column, and you came up with that 1,186 hours. Now extend it by the work activity method, you come up with 1,000 hours. Now you can do the math to know what the multiplier would have been to get it to the 0.75 that you would have applied to the 1,100. So follow that. It's very simple to do that calculation. Okay, now I want to do a different example for you. And the next example is going to be more of an industrial type example. So we got an isometric drawing. This is just, it's by Chevron, if I remember right. We'll pull it up in a different software so that you can really see it just a little bit better, and I can maneuver around and look. So this is a Chevron isometric drawing. And it's got items taken off, and as you see, you know, you got your field weld joints, or I mean your shop weld joints represented by the circles, and you've got some field weld joints in here represented, you know, by the X's. But at any rate, we're going to strip this off. It's got 4 different spools attached to this one line, this is the one ISO. And I've done it in a different spreadsheet, and I've got different tabs here on the bottom doing it the component method. Now, if I would have done it the old component method, this is what we would have come up with. I did it by spool, so per spool, these are the pipe, the fittings, the flanges, the T, the 90-degree elbow by spool. It's all 8-inch in size, the quantity, and then taking off the hours straight out of the WebLEM on the component method, giving us a total per spool. Okay, and then I recapped it over here on the right-hand side, and that drawing I just showed you, if we were to take it off, the normal method would be 121 hours. Now if I take off that same drawing using the new work activity method, I'll come up with I've got more items that I have to put in there. So that same first spool, now you'll see we have the pipe flange, but also I've got to add a bolt up in there. There's the T, the 90, but now I need a cut and bevel. I also have a field fit up and weld on that. So I'm going to leave, you know, a random or whatever, 6-inch random, and I got to make a cut. Now I've totaled this using the new work activity method labor hours, and I come up with this spool's 45 hours. Then I've done that for the next spool, the third spool, the fourth spool, and totaling it up over here on the right. So I've got 87 hours worth of labor now doing it the work activity method. Yes, sir?
Do you have an average of labor hours saved from using the component method to the work activity method?
No, there isn't, and I don't know if we'll be able to directly have a correlation, because it all depends on the mixture of your back-to-back fittings, because then you wouldn't need cuts, you wouldn't need the extra weld. But I will tell you that on this particular one, it was right at about 20%. I mean, we'll see that in a minute because I'm going to compare them side by side, so good question, but I really believe it's going to depend upon the mix. If you're doing something that, you know, also has corridor piping along with, you know, your boiler room or energy center piping, you know, in the energy center is going to be a much higher percentage of what that savings is going to be, as opposed to getting out in the corridor and just going. It's going to be more of a one-to-one with no savings out in the corridors, because you don't have the back-to-back fittings, right? Okay, so the work activity method was 87 hours. The component method was 121 on that one ISO. So then if I really break it down and look at it, this particular sheet really puts it side by side and recaps it for us. Okay, so here is the component method with all of the stuff just added together. In other words, I totaled for the 4 spools in each one of these lines, so I just totaled up all the pipe, the total number of pipe, the total flanges, the T's, the 90s, all of that. There's our total quantities, and extended it out times the component method, coming up to the 121 hours. That's what we just saw a minute ago. And then the work activity method over here, and these are the labor units in the new work activity method, totaling the 87 hours. So now if we really want to analyze it and say, okay, well, why the difference? That's what the rest of the example really does. So to compare it, the component method, this method right here, the one that we've always used for years, had 6 8-inch butt welds that are not used in the new work activity method due to back-to-back fitting. So that's huge. There's six joints that you're not having to make. The component method also had 18 8-inch cut and bevels. Now when I ran this example of the coil that Tim did, and I saw the difference between those two, the component method versus the work activity method, I thought for sure I did something wrong. I haven't counted something. But then when I went back and really did the math on it, it is mainly in the cuts. You've got an unbelievable amount of cuts that you didn't even need. This example shows it alone. There's 18. And that lousy ISO that I just showed you, that lousy ISO right there has 18 cuts that I don't need. So a lot of labor, right? So then the component method also has 1 cut and bevel per standard length of pipe. Okay, so when you're putting together and you're stringing together pipe, we have to have a joint in there, right? Well, that joint also includes a cut. So for every 21 foot, I've also got a cut, a bevel, and a weld that I don't need. The component method then had 2% overall testing for hydro testing that the work activity method doesn't account for and needs to be accounted for separately. So if I were really look at where the differences are at, this is it. The cut and bevel, there were a total of 19.8, and the reason 0.8 is because you've got a cut every 21 feet. So 1 divided by 21 tells you what percentage per foot, right? So if I add up my whole total foot of pipe on there, that's where I'm coming up with, you know, it doesn't round to a whole number. So there's 19.8. Cuts that I didn't need, I also had 7.8 butt welds, and the reason again with that is because I have 1 butt weld per 21 feet, so 1/21 is what you would need for the conversion on that. And then the hydro test, 1 hydro test, 2.4, which is 2%, so there's 36 hours that is not included in the work activity method that would have been included in the component method. Okay, so now if I go and add that in, there you'll find that if you take the 87 that we totaled up over here on the work activity method, and I add back in all these things I didn't need, I now come up with 121.91 hours compared to 121.28. You know, so I mean, it's right there in the accuracy of the two methods. So that really explains it as to it's really you're really saving because of the cuts. There are some welds in there we didn't need, but you can see that the bulk of that was made up by cuts. And then another thing that I did to just throw some comparisons in there is I wanted to say, okay, here's a quantity of joint. This is for pipe, and this is just doing a comparison for you to kind of glue it together as well. So for pipe, we have one joint, and in that pipe we have handling, we have a cut, and we have some type of a weld, and then it subtotals, and then I'm going to throw 2% testing on it. This particular column here tells you what it is in the work activity method. This tells you what the number is coming out of the component method. So if I total it up, I've got 0.54 hours in the work activity method, and if you look it up in the component method, it's 0.53. Honestly, what that is there's rounding in our spreadsheets, the way that we've calculated our numbers. That's the difference. Now let's take a flange. In a flange, you've got handling, you have a cut, a weld, you have a bolt up like Tim was speaking of earlier, and then you add 2% testing on it. So out of the work activity method, it's 5.31 hours, it's 5.3 on the component. Now let's take a T. A T has 3 joints on it, right? You have 1 handling, 3 cuts, 3 welds, subtotal it, add your testing. The component method number is 12. The work activity method is 11,9952. A 90 working the same math. There's 0.812 on the component method, basically 813 on the work activity. Again, it's a rounding difference. And then a 45, same deal. So what I just wanted to try to give you some more examples so that it's kind of gluing this together so that you have, you know, you can make that comparison in your head. Okay? Are there any questions about the 2 spreadsheets that I showed and how we came up with those numbers? And I'll be glad to give them to you. You know, email you spreadsheets so that you can go back if you would like to look at it and, you know, at your own leisure at your desk and, you know, scrutinize those numbers. So anyways, so now, you know, it's really possible so that you can, you don't need to adjust for back-to-back fittings or account for any of these labor activities for the shop versus the field. Now, the one thing that I didn't take into account there, and I didn't want to muddy the water, is this. So in the WebLEM, we state in, is it the basic assumptions? Or?
All the handling.
Yeah, is it? Yeah, so on all of those handling tables at the very top, in the WebLEM, we talk about what the WebLEM committee suggests that your field versus your shop handling percentage should be. Okay, so let's back that up a second and think about this. So Tim described how a 90-degree elbow in the component method had everything inclusive for getting that thing up into place. But on the work activity method on 90-degree elbow has labor associated only with getting it into place. It doesn't have anything to do with, well, how much of that is you going to use in your shop and how much of that are you going to use in the field. It's the total handling labor. And you got to proportion that somehow. The LEM committee, we've debated this for a long time and then also used some data that each of the contractors had. And we've come up with this. It's a 16-84 split. So 16% shop, 84% field. That's not meaning that we think that only 16% of the fabrication could be done in your shop and then 84 of it done in the field. That's not what that means. Because today, on the component method, you'd certainly have used a much higher number. Man, I think I can fabricate 40% of the job in my shop, 50% of the job. That's not what that means. What that means is, on that particular fitting, that 90-degree elbow, how much of the total labor am I going to need to get to handle that through the shop or in the field? And obviously, once I have a spool made and I got to go get that item installed in the field, the bulk of that installation labor or handling labor is going to be getting that thing up in the field, right? So that's why that number is 1684. Okay, so these calculations didn't take that into account. So if you want to apply that, you certainly need to then figure out, you know, how much you're going to need for shop versus the field, and the LEM committee suggests that 16 versus 84.
Can I add one thing to that?
Sure.
So that 1684 split only applies to the handling labor items. The joint labor, you know where those are going to occur, whether it's in the shop or the field. The cutting, you know whether that's in the shop or the field. The only split that you have to apply has to do with the handling and installation labor components.
Right. Good point.
So for pipe, valves, and fittings, you're going to find one component in the work activity method is called handling and installation. And on the top of those tables, that's where what Ron just described is the note that says, we recommend you start with 1684. Based on our studies, that's a pretty good average based on most shops and most field installation circumstances to start. Okay?
So bottom line is the work activity allocates those hours associated with those activities extremely accurate because we've seen how that breaks out. So, you know, you might be sitting there saying, well, but okay, that's great. I do all commercial work and this isn't for me. That's cool. You know, just do it the way that you've been doing it because we still have and maintain the old component method. Those will always be there. And you've already got your multipliers working for you. That's fine. You can go ahead and use it the way you had. But if you do want to use a new work activity method, now it's all broken out for you. So basically, you know, you can start using that right away. The new work activity method, as Tim mentioned, you know, it needs to be in your software with, you know, 28,000 data points that have been issued right away. It's a pretty good task for you to have to go back and sit down at your desk and, you know, get all those items put in and get the labor associated with them. So you got to lean on your software companies in order to get that put in.
By the way, we want you to do that. Our perspective is that until pressure keeps getting put on the software vendors like Ron, and it's going to take one guy at least to publish them and then guilt all the other ones into doing it, you know, you aren't going to get the value of this that you could. So start beating on your software vendors to get those programmed in, and it will benefit everybody if we do.
And once it's in, you know, this is a huge little comment here. We want to make sure that you give us feedback. You know, we only get better when we have feedback from, you know, the membership on our units. You know, and we're constantly scrutinizing that type of stuff, and you know, during our meetings. And then I thought I'd have Tim go through just an update here on what the committee's doing and what we're working on to kind of give you a flavor about the committee and, you know, our projects. So.
Any questions about the work activity method first before we go off of that? None whatsoever? Yeah. You mean in your takeoff, like for your material count? It would depend on, are you doing it manually in an Excel spreadsheet, or how are you counting those joints? So Ron would be, I mean, you could talk about how your perspective from a software vendor is doing it, but I would think you would go through and count the number of joints by type, and you'd have a tick sheet or something that would list those, and for every bolt up, you're going to have bolts and gaskets.
So today, in anybody's software, you know, it's a good question because today you have a flange that could automatically spin off the bolt ups so that you don't have to count them. The software is going to work the same way. It's still going to spin off the bolt up. But today, when you do it the component method, your labor for that bolt up is 0. You don't get any labor for it. You're just getting the count for it, so you know how many you order, right? Well, the same thing is going to happen in the new component method. Your software is still going to spin off that bolt up, unless you're counting them specifically, which that's what this was really made for. But if you're not, and you're just automatically spinning them off, it's still going to do it. It's just going to extend it by a different labor column now, the work activity method, and that one has labor on it, right?
It's going to be by the joint column.
So that's right. So I would still argue that, you know, that's the whole purpose of the work activity method is so that you can accurately count these things and don't let them just automatically get spun off.
What other questions about work activity method? Okay. Some of the other things that our committee is currently working on. So the next kind of direction we need to go, the 20-some thousand units that we've published really addressed a lot of pipe fitting work. We started with carbon steel butt weld, which is kind of our standard benchmark for everything. And we did some copper, and we did grooved, and we did stainless. We haven't done any of the the heavy metal stuff. None of the chrome alloys or anything have been done yet, I don't think, at this point.
No, those are all done. So,
Are they all? Okay,
yeah,
so the chrome's done.
Anything butt weld, anything. No
Anything
matter
butt
what it
weld is finished.
no matter anything socket weld, those are all done, those
Okay.
systems. The threaded is done in 3,000 and 6,000 pound. We've not done 150. And so what we were really trying to do was come out first to be able to do for industrial type contractors that are using, you know, got isometric drawing, you got butt weld stuff, socket weld or 3,000 pound socket weld fittings or threaded fittings, right? We also did the grooved so that we could do a comparison to that.
Right, so all the groove for the same alloys and wall thicknesses are done.
Right.
But none of the plumbing is really done. So cast iron, no hub, copper sweat, PVC, domestic waste and vent, and pressure pipe. It's probably the next direction we have to go. We're also going back and final reviewing plastics. So over the last 3 years, we've published a lot of new plastic material, if you've paid attention to the updates. You know, both pressure and non-pressure, every different kind of plastic you can imagine, and we're trying to clean up the nomenclature that's used for those, because we get a lot of questions about why isn't this particular pipe covered, and the person is using a trade name and it's not a generic name, and the generic name might be there already as an example, and we're trying to make that more clear. So when you go into there and you're looking for Aquatherm, good example, what are you looking for? You know, and we can help direct you to that. We are reviewing saddles, stub ends, and nozzle welds, and the challenge with that is that, you know, we start then talking about, well, what's the length of the weld? It's not the same as the circumference of a pipe. If I'm doing a saddle, it's an odd shape. And if I'm getting down to the point of wanting to know, you know, labor hours just to make that weld, I need to know the length of the bead probably. And so we had to actually get into some geometry and try to figure out what that is for saddles of different sizes. Aquatherm, the example I used, we're going back through because what we have in the WebLEM right now, that's the closest we have, is a conservative estimate for the way Aquatherm pipe goes together. And that particular material has become pretty common across the United States at this point.
Does anybody use Aquatherm in here? Has anybody had experience with putting Aquatherm in? Nobody? Okay. We're actually looking for some contractors to get feedback. I mean,
right.
It's funny because Aquatherm will tell you how quick that stuff goes in, you know, but they want to, it's like in a controlled environment, you know, either the heat plate for the butt fusion or the mandrel for socket fusion, you know, is already heated up, and, you know, he says, oh, it takes, okay, start. It takes 20 seconds to make that joint. Well, that's not what it takes to cut the pipe, get the measurement, cut the pipe, you know, heat that thing up. We get it that after you heat that hot plate up, you're going to, it'll stay hot, but still, the way the manufacturer believes that unit should be and the way the contractor actual time is. And, you know, okay, so he's got his ladder up over here and he goes over to grab something and, you know, somebody else grabbed the ladder and took it over here, or his extension cord that he just ran out. You know how a normal job site is. It doesn't have those conditions put in with the number that the manufacturer wants to tell us that it takes to do this. So the whole point of this is the Aquatherm, like many other manufacturers, have come back to us and said your numbers are way too high. So, you know, can you relook at those? Well, we can only relook at them based on information coming back from the membership. We formulated them using the same empirical formula that we use for doing everything else. So, as from our perspective, it's bang on, but, you know, we need feedback from the membership. So, if those numbers are high, we'll certainly go back and adjust them.
The thing with that, so we get the same comment, for example, from Victaulic, and we're looking at the Quick Vic, or the installation ready as they call it, which if you've used that product now, you know you're not taking the bolts, nuts apart. There's only 2 of them. You slide it on, you tighten it up, you're done. And they want to put a stopwatch on the activity in the shop, and the fact that we now have joint labor separated has brought this more into the spotlight. And as soon as we published joint labor, every manufacturer is looking at their material and joining method and what that labor unit is to do a comparison. So the first thing that we discovered in this discussion is that they're all doing the same evaluation. They're all doing a shop study of how long it takes them to make a joint, like Ron said for Aquatherm, and they're saying our labor unit's high. We're saying, well, based on that comparison, it is. But let's just take a carbon steel butt weld. That's the basis for how this whole system was developed to begin with. And I know in our shop how much time it takes us to make a 10-inch butt weld. I can watch the guy do it. He can do it in 10, 15 minutes. If I look at the labor unit, it's 6 times that. Why is that? Because of all the things Ron just said. It's all of the non-productive time that is on average occurring on every job and in every shop. And so we can't just say, well, that labor unit ought to come all the way down to 15 minutes, because if we did that, we'd all go bankrupt by bidding stuff way too low, because the non-productive time occurs and it's real. So, for example, our challenge with Quick Vic or Aquatherm is to determine, how much to those units should they come down. And it's not an easy answer, which is why we need some feedback from contractors to know how much, for example, are you factoring that particular material and joining method compared to everything else you factor. If you're factoring it about the same, the units are probably right the way it is. We're not going to find that the units should be 1/3 of what's published. That's not the case, because so much of the time that's in the labor unit is non-productive. So that's right now what's in front of us. Is that the last slide, Ron? And our committee, real quick, our committee meets twice a year. Usually within 30 days after our meeting, we publish an update. Ron mentioned those updates. I'll come back to your question in just a second, but I wanted to show where you can find those updates. So on the website, if you didn't get to your updates and you have login credentials, you can go here and you can find every update we've published. And if I go pull this up, which we published just a little over a month ago, you'll have all kinds of data on what was published. It tells you how many labor units, how many revised labor units. I can actually pull up a table from that, and what's highlighted on that table is what's changed. In this particular case, that's a whole new table that was published. So the way the software works on updates is for 6 months or a year, 12 months, the item stays highlighted yellow. So as an estimator, when you want to keep your units in your estimating software up to date, you get that email. You click on it, it takes you to the table. Only the ones that are highlighted are the ones you need to update in your labor tables to be current with the current labor units that we have published. Okay, then we had a question back here.
Yeah, your unproductive time measure, do you have that for welding, or is that per contractor? I mean, you were mentioning the Aquatherm and the Quick Vic and not having an unproductive time measure there. Did I miss something in
So what the comment is that both Victaulic and Aquatherm, and they're not the only manufacturers, we publish the work activity methods, and it says now that the joint labor for a Quick Vic joint is, let's say, 15 minutes. And what happens is they hand us a DVD with videos from their shop of showing they can do that, in 6 minutes. And they're saying that's what it ought to be, because here's our proof that you can make that joint in 6 minutes. And the problem with that is that it's a shop circumstance and doesn't take into account any of the potential non-productive labor that goes on a job. So the whole basis for the labor estimating method MCA has developed is the labor units, when you add them all together, will include non-productive time. It includes that. So, if you have less non-productive time, you're factoring more aggressively than somebody else that doesn't. But we don't identify how much is non-productive time. We don't tell you. It's just it's born into each labor unit. It's the best way I can say it. If you did a time study in your shop, you'll figure out how much a percentage of it in your mind is non-productive. But, the reality is, you telling me how long it takes you to make that joint in your shop isn't the information we want. What we want is when you did a whole install of Aquatherm or installation ready Vic or whatever, how did it come out total estimate on your MCA factor? That's what I want to know. Because now I know you've got non-productive time built into your units, which is what we have in ours. That information is really important to us. And what we try to do, our mission, is to try to get to a point where you would factor every system about the same. So where we find or get feedback that somebody's factoring a particular system much higher than something else, we dig into it. And if we find that's true across the board, we revise and republish the labor units. An example of that, for example, is a plastic pressure pipe. Above 6 inch, we have found that the old labor units, this was republished 2-3 years ago, were way short. And if you took off 12 inch to 24 inch pressure pipe 10 years ago and used the units that were in the LEM, you got your butt kicked probably. And it's because that stuff is really, really hard to fit together, and it's a lot more difficult than what it looks. And so we've had to apply different joining factors to those to get them more in line with what they should be. And what we're trying to do is give data to the contractors to use so that as time goes on, you factor everything about the same for your operation and the way you do business. That's what our goal is. What other questions? Any other comments or suggestions, things our committee ought to be looking at? Then I think we're wrapped up. Thanks for coming today. I'll turn it back over to Bob. Is he still here? Bob is here. And I think we're finished. We'll hang around for a little bit if you've got questions you want to ask offline. The last thing I would answer is, my home's here in Kansas City. I'm available to anybody here locally if you have questions about the LEM committee or the data that we published. I'll always answer questions if you want to get in touch with me. I'm at U.S. Engineering, so just give us a call.
All right. Thanks, Ron and Tim, for